Quantum field theory predicts a vacuum energy density 120 orders of magnitude higher than what we observe. When a theoretical calculation fails at this scale, the mathematical grid we use to measure the universe shatters. The 88% mass discrepancy we call dark matter is a related symptom. Both errors suggest our baseline measurement of spacetime is incorrect. This diagram illustrates Euclidean anxiety, the effort to project a flat, three-dimensional grid onto an organically curved manifold. The grid lines cannot reconcile with the curvature, leading to a structural failure at the edges. Applying linear tools to curved space generates a mathematical residue. We categorize this residue as dark matter, though it represents a blindness in the observer's frame rather than a physical particle. To resolve this, we treat the quantum vacuum as a high-viscosity superfluid substrate. Spacetime is a physical medium in motion. Within this fluid, gravity functions as an omnipush. It is the total thermodynamic pressure of the vacuum seeking equilibrium, pressing inward from all directions. Measuring distance in a fluid requires the metric tensor. The grid lines stop resisting the medium and adapt to the fluid flow's grain. Just as a master butcher slices a primal cut without ruining the tissue, the mathematical blade must follow the Riemannian grain. Models that ignore this inherent viscosity require fabricated variables to balance their equations. Dark matter provides the mass necessary to compensate for a measurement tool that cannot see the vacuum's pressure. The dynamic liquid push equation maps gravity as total omnidirectional pressure. Overlapping 10-dimensional manifolds compresses them into a fractal Hausdorff dimension of 9.6. This leaves a 0.4-dimensional gap, a topological release valve for excess energy. Forcing all kinetic energy into a rigid, closed system creates a buffer overflow. The internal pressure eventually shatters the singularity's structural lattice. Calculating the manifold pressure through the golden ratio gives a primary value of 2803. Extracting the 0.4 fractional remainder yields exactly 1121 units. This matches the thermal signature of Hawking radiation, the universe's method of venting pressure to prevent structural collapse. This math dictates a physical requirement. Thermal friction must vent at a 3.6-degree tilt. Standard fusion reactors attempt to force superheated plasma through perfectly straight linear pipes, which inevitably creates catastrophic friction and structural failure. Aligning the hardware to this exact 3.6-degree angle allows that 0.4 gap to safely vent. Managing this pressure exhaust is the difference between a functional vacuum energy system and a failing closed-system reactor. Classical kinematics use 6 variables to track position and velocity, but these tools cannot monitor energy moving across fractional dimensions. This 24-variable tensor maps the manifold in 4 quadrants. Category A establishes the geometric grain. Category B maps kinetic movement and viscous drag. Category C identifies fractional seams. Finally, Category D quarantines human measurement bias, preventing Euclidean errors from contaminating data. Expanding into this 24-state subspace allows for hydrodynamic tracking, replacing assumptions of flat space with measurable fluid dynamics. A 24-variable framework creates a massive configuration space. Without an audit, this complexity can generate chaotic noise and false patterns. To prevent this, a 25th parameter, the level cut, acts as a central auditor for the entire framework. This auditor calculates recurrence strength across all variables. It determines if a pattern is a consistent physical reality or an anomaly in the metric tensor's covariance. If the pattern does not repeat perfectly across the matrix, it is rejected and honed. Data must survive the level cut to be considered valid. This V25 check ensures that only mathematically rigorous patterns are translated into the physical model. When the framework is properly aligned, the vacuum achieves equilibrium. Kinetic energy vents through the seams, stabilizing the breathing geometric lattice of the manifold. Fractal pressure cosmology provides a falsifiable framework for unified physics, grounded in the measurable dynamics of the 0.4 exhaust gap. The 88% mass discrepancy attributed to dark matter is resolved through the calculation of vacuum pressure. We no longer need undetected particles to balance the universe's mass. Space-time functions as a high-viscosity superfluid. Mapping its fractional grain provides a consistent hydrodynamic explanation for zero-point Hergé and dark matter.